Today we're going to address ions and isotopes. We'll start with ions today and we'll visit isotopes later on in another video. But the first thing I want to tell you about ions is that when we have atoms, most of the time they're going to have the same quantity or amount of protons, neutrons, and electrons. So, for example, an atom of oxygen should technically have 8 protons, 8 neutrons, and 8 electrons. With regards to electrons, they are very tiny. Negative charge, we've already talked about that. But the thing about that is because they are very tiny, they can very easily be gained or lost. So you will not have that equal number that we talked about. Typically, on the periodic table, metals will lose electrons, anywhere between 1 and 3 in most cases. Nonmetals will gain electrons. Now, here's an example of sodium. We can see here that we have a sodium, this is the Bohr model of sodium, and typically with this structure, you're going to have 2 electrons in the first energy level, you'll have 8 in the second, and you'll have 1 in the third and last energy level, so you have a total of 11 electrons. For sodium to become an ion, what will happen is it will lose one of those electrons. So the definition of ion is an atom where you do not have the same equivalent amount of electrons and protons, that an atom has either gained or lost electrons. In the case of a metal, is going to lose the outside electrons. In sodium's case, you only have 1, so you only lost that 1. Nonmetals will gain. So here is an atom of fluorine. You have 9 protons, 9 electrons. So the charge is 0. It doesn't really have a charge. It's neutral. It's balanced. But you can see that because this is a nonmetal, so fluorine will gain 1 additional electron, so you'll actually have what's called a -1 charge. It will form a negative ion. In this case, you have 9 protons, you have 10 electrons, so you have 1 more electron than protons. So your overall electric charge is a -1 charge. The way we write that is F, that's the symbol for fluorine, and then we have 1 negative, meaning that we have a negativity, so you have a surplus of electrons, and we have 1, the difference is 1. So the question is, why do electrons do this? Why does this happen to atoms? And the answer lies with the overall goal. Every atom on the periodic table wants to be like the noble gases. The noble gases are non-reactive, they do not form compounds, they don't have reactions, and the reason for that is the number of electrons they have. Every atom on the periodic table wants to have 8 electrons. We call that a complete octet. And the goal is to have 8 valence. So when I say 8 electrons, what I'm talking about is on this outside energy level, it wants to have 8. So looking over here, the goal is to have 8 valence electrons. Nonmetals will gain until they have 8. Metals will give away all valence electrons. Then the level underneath becomes the valence level, and it will have 8. So the word valence means the outside level. So let's look at this. Right here we have sodium. Look what happens if the sodium, if that 1 electron leaves, you can see that underneath it has 8. And so now sodium has 8 valence electrons, just like those noble gases. In the case of fluorine, it did have 7 on the outside, and again we call that the valence energy level. And if it gains 1, it will then have 8, just like the noble gases. Here is an example of what can occur. If you look, you'll notice that chlorine and sodium can have a great relationship because sodium wants to give away 1, chlorine wants to take 1. If sodium gives away that one on the outside, this level right here becomes the outside level, and it has 8 there. And if chlorine gains 1 more for its outside level, it will then have 8 valence electrons as well. So again, remember that metals give, nonmetals take, and when a metal gives away electrons, we call it a cation, C-A-T-I-O-N. A nonmetal that has taken on additional electrons is known as an anion, A-N-I-O-N. Remember that cations are going to be positive because they're giving away electrons, and anions are going to be negative because they're taking on additional electrons, and electrons themselves are negative. So on the periodic table, let me just take a moment to have you label this along with me so we can talk about what kind of ions are going to be formed. Now, group 1 has 1 valence electron, group 2 has 2, and groups 3 through 12 are going to have 1 or 2. Group 13 has 3 valence electrons, group 14 has 4, group 15 is going to have 5, 16 is going to have 6, 17 is going to have 7, and group 18 is going to have 8. The ions that will form are the following. When metals form ions, they give away all their valence electrons. So this will form a positive 1, this will form a positive 2. This will form a positive 1 or a positive 2 ion. Group 13 will be a positive 3 ion. 14 I'm going to skip for right now. Let's go to 15. Remember, these are all nonmetals over here. So instead of giving away their electrons, they're going to take until they have 8. So group 15 needs 3 more, so I put a negative 3. That means it's going to gain 3 negative electrons. And this is where it gets a little confusing because you typically think of negative as losing things, but you're actually gaining electrons. 16 needs 2 more, so we'll have a negative 2 charge. Group 17 will have a negative 1 charge because it only needs to take on 1 more electron. Now group 18, this group is actually not going to form ions because it already has 8. So thank you for watching, and if you have questions, let me know.